thanks very much for coming along tonight. If you're at the back and you want to come a bit forward there, so feel free to move forward. It's great to see so many people here tonight. My name is James Alexander. I'm the Program Manager of Incubate. And tonight, you're going to see 7 companies pitching who have just graduated out of our Accelerator program. First of all, I'm hoping a lot of you are on social media because we want to see these hashtags everywhere. And last time we actually got a trending in Sydney, so the challenge is for you guys to do the same again. SID Class 7 is for this demo day. Lenovo Innovate is our major sponsor, Lenovo, and at City Incubate is obviously our handle here. If you tweet at us, we'll retweet and invite. Secondly, that is my Twitter, so if you do not like any of the startups or have any criticisms, you can absolutely tweet me. I'm also on Snapchat, and I've been a Snapchat channel interviewing startups and founders and fun things like that, so you can also add me on Snapchat. Okay, to kick things off, I thought it would be very good to mention some of the rhetoric that we're all hearing right now in the space around innovation. I mean, in the last 6 months, it's almost like every second day there's some major news release or press article about how we can foster innovation, how we can be more agile, etc., etc. The thing is, at Incubate, we've been living this for the last 3 years. In fact, we're at the forefront of helping commercialize student ideas as well as research from university. Put simply, for those of you who have never been to a demo day before, we back students to products and services for the future. To do this, we have a really awesome team, which I'm really proud to be part of. It's myself as the program manager, Joe, who is our director of student programs, Lizette Lee, who's our community manager, Farid, who's our project coordinator, and our 2 in-house mentors, Nick and Shane, who unfortunately can't be here in themselves, Nick and startups. I'd like to acknowledge our sponsor before we get going. First of all, our longest sponsor, Data61, formerly they provide deep socialization within certain areas and also help with some of our advisory. Our program partner, City University, who is obviously one of our major partners here on campus, and we're very proud to be expanding our services across more areas of the university, but that announcement's going to come later in the year. And finally, our major sponsor, our principal sponsor, Lenovo, who've been a fantastic sponsor for the last 3.5 years, and they provide our startups with really cool gear like this, Android tablets, some of the latest consumer hardware, as well as supporting the program. But tonight, what you're going to see is 7 companies pitching. There's 8 companies that actually went through the accelerator, but only 7 going to be pitching, and I'll talk about that at the end. And these are them. There's about 15 entrepreneurs in this group. They're of multiples of ages, so from young to a little more experienced. And they're across multiple industries as well. Healthcare, mobile, consumer, enterprise, and of course, blockchain. Would be a startup which is about blockchain. If you don't know what Incubate does, and I know probably a lot of you don't, we give them a $5,000 grant, we give them a mentoring program, and we give them advisory and co-working space. And over the 14 weeks, we have sort of 4 areas we focus on. The first one is customers. Who are the customers? What's the problem they're solving? The second month is, what are they going to build? So what's the solution look like? What's the very first version of this? The third month is more about the business model. So what's their revenue model? How are they going to make money? Are they going to be able to sustain themselves? And then almost the last 3 weeks, we exclusively just focus on pitch. And hopefully those results will show tonight. If you're an investor in the room or represent one of the investors, I'm just going to give you a little bit of information. All our startups have some sort of traction. So it's usually an initial customer or a test customer. 6 months. And we've seen the ranges from 300,000 to 1.5 million on the library. Of course, we absolutely love experienced founders as investors, but we also look for early stage investors with deep industry experience. So if you're looking for a particular area, then absolutely come chat to me afterwards as well. And of course, we've seen angels invest anywhere from 500,000 to 200,000, so it really depends on the type of investor. I'd also like to introduce our panelists. So after each pitch, we're going to have 3 questions from our panelists. Can I ask Petra maybe to kick it off with just a quick introduction?
So my name is Petra, and I'm the director of ATP Innovations. And ATP Innovations is a deep technology incubator, and we've been partnering with Incubator, I think, since the very beginning. We're huge fans of Incubator. I think it's the best student accelerator program that we have in Australia and internationally.
Thank you. Did not tell us that. Anne, who's joining us for the first time at a demo, could you say a few words?
Hi, I'm Anne Miller, the Managing Director of Grupo Cano, the Sydney office. We cover Australia and Asia. Saying that, Grupo Cano is an international VC firm. We have 4 offices around the world. We have a portfolio of 16 companies, and we specialize in truly disruptive, innovative technology. Everything from quantum computing to desalination chips to a future solar technology. And so that's really, thank you very much.
Thank you so much. And finally, Liz.
Hello, my name is Liz Kalin, and I'm the founder and CEO of You Choose. You Choose is a catering website where you can order great office catering that's twice as tasty in half the time. So if you go on our website, www.youchoose.com, you should all be ordering office catering from us tomorrow for your office lunches. But I just want to say thank you so much for having me, and I'm really looking forward to the pitches of the startups. We've been mentoring the startups for this intake, and you're in for a treat. Thank you very much.
Thanks, Liz. So as you can see, we've got an active investor, actually 2 active investors, as well as a founder. So they'll be asking questions. But enough of me. We're going to jump straight into the pitches now. And for the first pitch, I'd like to invite Tom from Myriad to the stage. Thank you, Tom.
Okay. Hello, everybody. My name is Tom Norohu. I'm the founder of Myriad Technologies. And the vision of our company is to transform the way we sense our environment. And our technology lies in the fact that we use light to detect chemicals in a way that's faster and cheaper than what's currently out there. And to date, that's brought us to a revenue of $21,000. But before I go into the details of how we run, I thought I might just give you a taste of what kind of problems people are trying to solve by purchasing our technology. So I thought I'd begin with an example. Imagine you're working in agriculture and you're producing, for instance, honey. What you want to do is you want to quickly go from harvesting your honey to packing them into boxes so you can go ahead and make sales. But in reality, this process is slowed down because you need to get chemical testing done, often get samples made, send them to a third party, get it chemically analyzed, it comes back to you, and you find out which ones you can keep, which ones you should get rid of. This can take several days and can cost several $100s per little sample that you get done. So what we're looking at doing is fast-tracking this process altogether and going straight to doing chemical analysis real-time on the scene. So now the problem comes in is that the current technology that allows you to do this looks something like this. And it's pretty obvious, but it's fairly complicated, it's large, and it's expensive, and it's slow. So it's more of a research tool. It's great at what it does, but in terms of doing it on the scene, it's a little bit more difficult. So what we're looking at is replacing this technology with what we've developed, which is what we call the Myriad spectrometer, shown here in blue. So in order to develop this product, we focused on 3 main things, which is number 1, to make things smaller 50 times in terms of volume. We're also increasing the speed that we can do chemical analysis so we can do it real time by more than 1,000 times. And we're also reducing the cost of the device down to 1/5 of what is currently out there so that it's more adoptable by people working in the field. And this is a product that we're taking to market. So just a little bit about that market. So this field of using light to detect chemicals is what we refer to as the mid-infrared market. And in 2014, this was a $789 million market, which was growing at a rate of 54% per annum. Within that, we've addressed $150 million to be serviceable by us which is just the value that's equivalent to us giving our device to those people who are currently in the research sector selling using lasers and light sources that require our technology to analyze these chemical analysis. So that's the space that we're looking at going into. So in terms of who we're competing amongst this space, so our two main competitors are shown up here. And as you can see, they're more very lab tabletop devices, very heavy. And I just got the device over here actually. And our device is the only handheld one, which I've actually got the most recent one we just made recently. So you can come take a look at this later when you're over the building over there, but you can come take a look at this. Okay, so that's the size. In terms of the speed of the device, these other ones take several seconds in order to do one chemical measurement, so whereas our one's improving that by 1000x. So you can imagine if you're in a production line with chemicals flowing and you want to really quickly measure contaminants, you want the fast resolution. And then finally, the price point that we're sitting at is around the $15,000 mark, which compares favorably to our competitors. So just a little bit about the team that came up with this. So this is our two-person team. That's myself on the left here. I just finished my PhD in physics at this university last year. I spent the last 4 years developing infrared lasers and detectors and presenting all those results to an international audience. My co-founder there is on the right, it's Darren Hudson, who's also a PhD in physics, currently a senior lecturer at this university, and also the project leader for the mid-infrared photonics group. So through Darren, we've got a very strong connection with the international research community. What we've come up with in terms of the business model is we're looking at currently going through a beta phase campaign, selling these devices at a price point of $7,000, and we're looking at scaling this up once we get into full production mode to doing it at a price point of $15,000. Where has that brought us to today in terms of traction? So we started off by targeting university researchers, which we're very well connected with, and had our first test user in December 2015, but ever since then we've had $31,000 in revenue. I'd like to mention that's only really the beginning because those people just came on board through word of mouth, but we're now looking at improving this sales cycle by contacting them directly. And in the last 7 days, we've had 9 strong leads that are hoping to convert into sales. And on top of that, we've also got another 350 prospects to contact in the same field. So moving on from here, we're looking at in the next couple of months, looking at $400,000 investments for the next 12 months. That's going to include key hiring of staff, a few other things, but mainly in terms of expanding our team in terms of getting a full software engineer on board, upgrading our manufacturing so that within 12 months we can have 100 devices sold, which is looking at a revenue of $1.5 million. So just to finish off with, once again, my name is Tomonori Hu, I'm from Myriad Technologies. If you're interested, we'd love to chat with you. We're the ones making chemical sensing faster, easier, and smarter.
There's actually 3 seats just down here, so feel free to, don't be shy, feel free to come form up. All right, questions from our panelists?
Thank you for a great presentation. I wanted to know a little bit about the market size and the different segments that you have identified. I understand that it's obviously faster, cheaper, better, as you say, no moving parts, portable. Who cares about that? Well, you mentioned honey as a use case, that's obviously a very small market.
Yep.
Where do you see the market for this and how big is that market? Because if you're asking for money, I won't be able to work out my return.
Okay, sure. So the honey was just one example, which is a bit closer to home, but that itself is sitting on the $500 million kind of mark. But we're looking at what we're really excited about is taking these to sectors like remote sensing, such as doing methane sensing, which is a very big global warming, danger gas. So we're looking at doing these things to specific sensors which we're able to sit by themselves and be able to do these measurements. Yeah.
So that was a great presentation. I just had a question with regards to the contaminants that you're actually measuring. So I'm a dietitian, so I know that that's safety. So I know that you had given the example with regards to honey, but I wanted to ask if you could give a couple other examples as to how this technology would be used in food production.
Okay, sure. So our technology, which uses spectroscopy, which is a technical term, but it's we operate in a field which is called the infrared, which is essentially what we call the fingerprint region of molecules. So every molecule actually has a very specific signature there. It's almost like the DNA of the molecule. And through that, the The advantage of our device is we can tailor it to look at specific chemicals. And then once we know the signature, we can create the device around that in a really short turnaround time.
And how many chemicals does your current measure? Or how many can it measure?
You mean this one here?
Yes.
You mean how many different types?
Yeah, so, you know, do you have to set it so that it is looking for a certain contaminant? Does it?
Yeah, so that's part of our strength is that we can set it to do this. This one, for instance, here, you probably look around, you're looking around this 10 different chemicals. This is for a specific application for our last customer. Yeah. So that's the kind of scale we look
Sure.
at. Yeah.
Is it as accurate as competing technologies, or do you have to give up accuracy to get the small size and the portability?
That's right. There's a little bit we give up. So the big machine that I showed you at the very beginning, that's a great device. It does solve a lot of issues. The problem is not everyone wants to sense every chemical in the entire universe with one device. And the trade-off for that is it gets expensive and it gets bigger. After doing our interviews with people working in the beverage industry or people working in the honey industry, they only want to really control a handful of chemicals. And that doesn't exist out there.
That's what I was going to actually follow on with that question. When the price, is there flexibility in the price model to sort of cater for different areas? For example, the food industry might not need as many chemical detectors as opposed to going into industry, does industry with mining or agriculture, where you might have a wider range of applications that are needed and therefore more cost on the development.
Yes. So the current price model that we've got is for our initial target market, which is the university researchers. And there's a few things we've considered being researchers ourselves, how we came up with that. But that's for the researcher side. But I think, yeah, it would evolve when we go into other sectors, and it'd be more precise. So I actually think we could go lower. But I need to have a conversation with the specific
And the
customers.
question we have to ask, what about your patent position? Is this a proprietary technology that is protected?
So at the moment, all of our IP that surrounds the device here is in the form of know-how, and we're actually in the process of getting professional advice, seeking what directions we can take in order to protect our device from obviously the bigger players that can come in. Yeah. But that's also part of our the strength at the moment is that we have this really quick idea that we can go from someone's problem to a device within a matter of less than a day, which is big devices cover by having a very expensive device already, but we can make specific devices for people.
Fantastic. All right. Thank you so much.
Miriam actually studied photological is a perfect example of researchers coming up with an idea and actually going ahead and executing. Okay, our next startup. I'd like to now invite in from Iridium Dynamics stage. Please give me a welcome.
Hi, I'm Ian Cormier, founder of Iridium Dynamics, and we're manufacturing a novel UAV, also known as a drone, to improve production efficiency in agriculture. So the agriculture industry, worth $150 billion annually in Australia alone, will become one of the largest consumers of drone technologies in the next few years. Applications for agriculture drones are numerous. Crop analysis and crop growth, detecting weeds in farms, measuring feed volumes across pastures, spotting pests before they can strike. And what we're focusing on firstly, infrastructure inspection, inspecting troughs, dams, and fence lines, an essential task to ensure the safety of cattle and sheep. Automating this process using aerial imaging reduces labor hours, which is one of the highest costs to grazing. These remote properties must meet a number of criteria. Missions are frequent. Multiple inspections are required daily. Images must be high resolution, with pixels representing 1 to 10 centimeters on ground. They must cover a large area. Farms in Australia range from thousands to millions of hectares. The largest cattle station in Australia is actually larger than Israel, even when servicing very remote properties. These can be hours from the nearest towns in Australia. Current approaches do not solve all 4 requirements simultaneously. It's not possible to run daily missions using manned aircraft or satellite flyovers, or by renting the services away to these remote locations. Commercial drone technologies available for purchase, usually within the hobby category, either do not have sufficient area coverage or they require piloting experience. And our solution, The Halo UAV system is the only solution which fulfills all 4 requirements simultaneously. Our solution is a 2.4 meter wing size of this table. Its 2-hour flight endurance gives it a range of 150 kilometers, or enough to cover an area of 2,000 hectares. Equivalently, a 4 by 5 kilometer property, if you want to think about it like that. Fully autonomous flight with reliable, no need for previous piloting experience, and the real winner, weighing in at just under 2 kilograms, it will not need an operator's license under upcoming legislative changes in Australia and the USA. The aeroplane spends most of its time in a standard proven aeroplane configuration. It's stable and has very low drag, which makes it very efficient, perfect for long-range aerial imaging. It transitions into a hovering rotary configuration, where the same wings are used to generate lift. This is a drastic improvement in efficiency over other hovering techniques. Vertical takeoff and landing means that it reduces risk at critical parts of the flight, and this rotary configuration is patentable. Here's a demonstration of a tethered hovering prototype. So I'm Ian Conway-Lamb, up here on the left. I'm the sole founder. After graduating from engineering and science, I've been working at Microsoft mechanical hardware systems. I have 2 advisors on board, my brother Chris, an aerospace engineer, and Mike Bailey, the CEO of UAV Vision. Between them, they have experience developing numerous aircraft, commercial and military components, and taking these to the Australian and international markets. During the development phase, we'll be partnering with farmers around New South Wales to help fine-tune the specifications of the product, and they'll receive a discount on production models. Selling at a $15,000 price point gives a 75% gross margin at production quantities. And the hardware is just the start of the product. We also intend to offer control and analytics software, which we'll provide as a service. 53% of Australia's land mass is allocated to agriculture, which gives us a gigantic market. The Australian farming market size is $2 billion, based on 135,000 farmers selling at $15,000. But we also expect to move to overseas agriculture markets, particularly the USA and South America. As you can see on the map, these also have very, very large farms indicated in blue. We also foresee the use of this technology in the military, resources, and disaster relief segments. Now, taking a look at our 18-month milestones, I'm self-funded today with $15,000 to develop the next 4 prototype iterations. By mid-year, we'll be payload testing with our early adopter program. At the end of the year, we'll be shipping the first products to them. I'll be looking to raise $600,000 in 3 months. That will be covering salaries, including a mechanical, aero, and the materials and tooling required for manufacture and electrical prototyping tools. I'm production efficiency in agriculture.